In this lesson, we'll be continuing to build on knowledge on finding the equation of a cubic function. This is part 2 of 4. So it will be a series of 4 videos. In this lesson, I'll be showing you how to find the equation of a cubic function when you're given a turning point. Then we'll be digging deep into the fundamentals of how to use the turning point to find the equation. So I'll be showing you some quick hacks and how to efficiently answer any question relating to finding the cubic function and the turning point. And by the end of this lesson, you should be able to confidently answer these questions. So suppose we're given this exam type question where we're given the graph of k of x, which is equals to 3x cubed plus mx squared plus nx plus 1, and we are told that it has a turning point, and this turning point is at, I'll just abbreviate the turning point to be TP, and this turning point is at minus 1 is to 2. So how do we go about finding the values of m and finding the values of n? So since this is a turning point, there's already a hint as to how we're going to solve this question. And I'll just remind you of that hint because I know you possibly know it. I'll just really remind you of it. So we know that this is definitely our x, and that will be our y coordinate. And why is this important? Remember, when you're finding the turning point, you always say the first derivative of a function, which in this case it will be drop the exponent, which will be 3, x, subtract 1 from the exponent, which will be 2. Repeat that, drop the exponent 2, subtract 1 from the exponent, it will be 1. Then in this case we drop the invisible 1, which will be 1 times n. Then if we subtract 1 from the 1, it will be 0. Any number raised to the power of 0, it will be 1, so it will be n to the power of 1. And so when we're given this, we know that to calculate the turning point, we would say the derivative should be equals to 0, right? So we go ahead and say 3x squared plus 2mx plus n is equals to 0. So ideally we would solve for x, and when we solve for x, we're going to get the x coordinate of the turning point, but we don't need to solve for x now, right? Because we are given what the x coordinate of the turning point is. So what we need to do is to just smartly substitute that x coordinate of the turning point, which is -1, where there's x. Everywhere where there's x, we plug in -1. Then we're going to get -1 squared is +1. +1 times 3 is 3. And positive 2m times -1, it will be -2m plus n is all equals to 0. So you can see now we have some form of equation. So that's the first important part to remember, how to use your x value in a turning point really to derive an equation over there by first deriving and substituting that x coordinate of the turning point. The second part that you need to be aware of and know is that this turning point lies on this graph, meaning that we can substitute the values of x and y directly into this equation, meaning that where there's y, we will substitute 2, and where there's x, we're going to plug in -1. We have -1 squared plus n, -1 plus n. Now we're in the process of just generating a second formula or second equation. And in this way, you see that we're going to have simultaneous equations. So -1 cubed will be -1, and -1 squared will be positive, so it will be positive m. N times -1, it will be -n plus 1. So negative and positive will cancel, and we'll be left with 2 is equals to m minus n. As you can see that. So now you can see that we have two equations. We are almost at our answer. So if we have two equations, what do? We can use a smart technique, simultaneous equations. We can simply say this is equation 1, and that is equation 2. So we just need to generate equation 3. We can just take equation 1 and make n subject. n can be subject. If n is subject, we're going to take everything to the other side of the equation. We're going to have 2m minus 3. We're going to just take this 2m and 3 to the other side of the equation and leave n. So this will enable us to have equation 3. Then we can just say substitute equation 3 into the unused equation, which will be equation 2, meaning that where there's n in equation 2, we're going to substitute 2m minus 3 with this n over there. How will this look like? It will be 2 is equals to m minus 2m minus 3, which will be 2 is equals to m minus 2m plus 3. So what do we do now? We just need to solve for m. Take the 3 to the other side of the equation. You have 2 minus 3 is equals to, on the right hand side you have m minus 2, which will be minus m. So we can see that. Let's make room for our work. If we take it to the top, we have 2 minus 3 is equals to minus m. 2 minus 3 is nothing more than negative 1 minus m. So we can divide both sides by negative, where we can see that our m is equals to 1. That's our m. How do we find our m? We substitute this value into our equation 3. Remember equation 3? Why do you substitute into equation 3? Equation 3 already has n as subject of the formula. So just going to substitute it in there. And we're going to have n is equals to 2 into 1 minus 3, and n is equals to 2 minus 3, and n will be equals to negative 1. So we've solved what n is equals to, n is equals to 1, and we solve what m is equals to. So to summarize everything, we found the equation of k of x. So the equation of k of x now is k of x is equals to x cubed plus x squared minus x plus 1. And the key takeaways for this video is to, when you're given the turning point, always remember that the turning point, the first derivative of that function equals to 0, will enable you to find the first equation by substituting the x value that's given in the turning point, x and y. So what you need to know and remember is that you just need to substitute the value of x that's given in the turning point into your first derivative, whatever function it is, and then it will give you equation 1. And then the second part you need to remember is, when you're given any function, for example, I still use k of x as reference, k of x is equals to, you can substitute the turning point into the function. Where there's x, you substitute x, where there's y, you substitute y into the function, and this will help you generate your equation 2. So at the end of the lesson, or the end of the question, you have equation 1 and equation 2. Then you're going to solve them simultaneously. So if you found value in this video, please hit the like button and be sure to look at the next video, which is part 3 for finding the cubic function using 2 turning points.